In this lesson, we're going to look at standard deviation. So first we need to look at the term deviation. So deviation, it's the difference between the data value, so the actual number that you have, and the mean, which you'll end up having to find yourself. So if we look at an example, with this data set, first step, we need to find the mean of this data set. So we add them all together, all those values, and we divide them by the 5, which is the number of data values that we have. We get 25 over 5, which is 5. So that's our mean, or our average. Then if we look at the deviation, we look at how far each data value, so each one of these is one data value. We have to look at how much each one of those varies from 5. Okay, so the deviation of 1 from our average of 5 is just 1, which is our data value, minus the mean, which is 5. And you can see there that our deviation is a negative number because 1 is less than our mean, which is 5. Okay, so when we look at 3, we have 3 minus 5, so our data value of 3 minus the mean, which is 5, gives us negative 2, so a deviation of negative 2. Our data value, which is 5, which is right on the mean, has a deviation of 0 because it doesn't deviate from our mean at all. And then our last two values, 7 and 9, we subtract 5 from them and get 2 and 4. So you can see that when a value is less than the mean, your deviation will be negative, and when your value is higher than the mean, your deviation will be positive. Okay, so the standard deviation, this is a measure of how far the data is spread out from the mean, and it's denoted by the symbol sigma. So this is sigma. So we find that with this equation here, and it looks a bit confusing because of that big Z sign, which just means sum, but really all it is we find our deviations, we square the deviation, we then add each of those together and divide them by the total number of data values that we have. Okay, so high standard deviation, this just means that the data values tend to be spread out over a large range away from the mean. So in this example here, our mean is at 150, so right here. And you can see that a lot of our data is below it, so a negative deviation, and a lot of our data is above it with a positive deviation. So that's going to give us a standard deviation, a large standard deviation value. If we look at this other data set, we have a low standard deviation here. So the general number, or most of our data values, are very close to the mean. So our mean is here, and as you can see, most of our data values are kind of in this range here, very close, and there's very far that are spread out far away from that data value. Okay, so our steps to find the standard deviation are given here, and we'll run through a few examples. So for this data set here, we want to calculate the standard deviation. Our first step, calculate the mean. And we get a mean of 8. That's by adding each one of those data values and dividing by the total number of data values, which is 6. Then what we do is we build a table. We have our data value here, so our first one is 5. Our next one, when we order them, is 6. Our next one is 7. Okay, so these are put in order of least to greatest. And then we find the deviation. So we go 5, our data value, which is here, minus 8, which is our mean, to get negative 3. Likewise, we take 6. We subtract 8 from it, get a value of negative 2. Going onwards, 7 is our data value. We subtract 8 from it, so 7 minus 8, we get negative 1, and so on. So this is how we find our deviations. Next step, we need to square the deviations. So all we do is add another column in the table and took this value of negative 3, squared it. We got 9. Negative 2 squared is 4. Negative 1 squared is 1, and so on. Okay, step 4, we want to sum the squares. So add each one of these rows together. 9 plus 4 plus 1 plus 4 plus 9 gives us a total value of 28. So the next step, divide the sum of the squares by the number of data values. So we have 28 is the sum of the squares, and then we need to divide that by 6 because we have 6 data values. We then square that, and that gives us a value of approximately 2.6. Okay, now we're going to look at a slightly different example. This one, we're given the data values in the form of a frequency table, and there's a few small changes you need to make when you calculate that. We now need to use a slightly different formula, and you'll see here, instead of summing just the deviation squared, we need to sum the frequency times that deviation squared. So we add an extra step in between 3 and 4, and we'll call it 3b, where you need to multiply the squared deviations by the frequency. And that's the frequency of that specific data value. Now you only need to do this extra step when it's given in a frequency table. Okay, so let's go through this example. Step 1, calculate the mean. Okay, so to calculate the mean from a frequency table, we need to multiply the data set by the frequencies. So 87 times 1 gives us 87. 88 times 2 gives 176. We then add those values together, and our mean is this value, which is the addition of the frequency times the data value divided by the total number of data values. So in this case, we get a mean of 91. Okay, step 2, calculate the deviations. We make our table, and in this case, we're doing our deviation of, here we go, do our deviation of 87 minus 91. This one would be 88 minus 91, 89 minus 91, and this gives us our deviations. Next step, we need to square these deviations. Okay, so we square each deviation, and then we multiply the squared deviation by the frequency, and this is done in one step here. So we've taken the -4, we've then squared that, and we multiply it by 1 because that's our frequency to get 16. The next one, we would have taken the -3, we square that, and then we multiply that by 2 in this case to get 18. And we do that for the entire data value, the entire table. We then sum all these up, so that's step 4. And then what we need to do is we need to divide the sum of the deviations by the number of data values, and then we square root that. And so we get a value of 8.5. Okay, so that's the end of the standard deviation video. I do encourage you to take the time to go back with both of those questions, try to do them yourself, and then you can play the video again if you need to catch up on any steps that you might not have quite completely understood.